This is Miss Lowe, and this is Chapter 2.3, Precalculus. We're going to be dividing polynomials in this section. You should follow along with your note guide as I complete this. The first thing you're going to do is the team challenge. I'm not going to provide a solution to this because you should be able to do this. Be sure that you find the zeros by factoring, find the x-intercepts, and state the end behavior. When you submit this note guide, this problem should be complete as well. We're going to work on 2.3, which is dividing polynomials. So our objective is to be able to divide polynomials using long division. And this will help us find factors of polynomials so that we can find their zeros. The missing words here are product, factor, and zeros. This says because polynomials can be factored, hence written as a product of factors, they can also be divided. Division of polynomials can be used to determine factors, we'll add an S to that, and find zeros of the polynomial. So you have to know how to do long division in order to divide polynomials. If you haven't done long division in a while, you can refresh your memory by doing these two problems. Do not do these with a calculator. You can check with a calculator, but you're going to do them without a calculator. Remember how we set up long division problems? You figure out how many times 23 would go into 22, and 23 doesn't divide into 22. So I'm going to do 23 goes in 226. The most number of times that would go into it without going over would be 9. So then I'm going to do 9 times 23, and I'm going to write that number below this. And then I subtract. And I subtract down. And I get 19. And I repeat the process. 23 doesn't go into 19, so I'm going to bring down the 7. 23 divides into 197, at most 8 times. And you figure that out by trial and error. It's going to be a little easier when we do long division. Then we do 8 times 23, and we write that product here, which is 184. Then we subtract, which is why I have the minus sign. And that gives you 13. Again, I bring down the 8. 23 doesn't go into 13, but it'll go into 138. And I figure out what's the most number of times it goes into it. That would be 6 times. Again, trial and error. 23 times 6 is 138. And again, I subtract. This is my remainder here. I have a remainder of 0. When you get a remainder of 0, that tells you that 23 is a factor of 22,678, and that 986 is the other factor. So we could write this number as a product of those two factors, 23 times 986, because it goes into it evenly. This is called the quotient of the division problem. 23 is the divisor. It's what you're dividing in. And 22,678 is the dividend. So if it divides in evenly, there'll be a remainder of 0, and therefore the divisor and the quotient would both be factors of the number. We're going to do that again with the number, with letter B. So we're going to do 61 goes into 5, 4, 5, 4, 8. I'm going to do this a little quicker. 61 doesn't divide into 5, 4, but it can divide into 545 8 times. 8 times 61 is 488. I subtract, and I get 57. And then I bring down the 4. If this number was higher, is 61 or higher, then I haven't figured out the biggest number that divides into it. This number of 57 has to be lower than 61. Now I'm going to divide 61 into 574, and I get the number 9. use a different color for that. 9. Now I'm going to do 9 times 61, which is 549. And then I again subtract. There's my cats. And I get 25 when I subtract. And I bring down the 8. So now we're going to do 61 goes into 258. And that would divide into it at most 4 times. 4 times 61 is 244. And then I subtract. I get 14. So my remainder is 14. That means that 61 does not divide into 54548. It's not a factor of 54,548. We would write this solution as 894 plus 14 over 61. You guys hear my cats meowing in the background? Shut up. So this is how you would write that solution. 894 plus 14 over the divisor. And this is called the remainder. So this is useful because it tells you if a divisor is a factor of the dividend. So we're going to move to the next page and we're going to do a practice together, A, and then I'm going to have you guys try B, and then I'm going to start a new video after this so that this one's not too long. So we are going to try to divide this linear factor, I know it's linear because it has an exponent of 1, into this cubic. Now what we could actually do is we could try to factor this and see if one of the factors is 4x plus 5, but we haven't done a lot of factoring with cubics unless it's by grouping. So we're going to try to factor it by using division to help us. If 4x plus 5 divides into 4x squared plus 13x minus 2x minus 5, if it divides into it without a remainder, then we know 4x plus 5 is one of the factors, and the answer would also be a factor, and then we could write it as a product of the factors. So you're going to ignore the plus 5. You're just going to look at the 4x, and you're going to think 4x times what gives you 4x cubed? And that would be x squared. And you write that up there. This is the same thing as saying how many times does 4x divide into 4x cubed? It divides into an x squared times. Then, again, the same thing we do with long division. We take that number or term, whatever it is, and we multiply it by both. So I'm going to do x squared times 4x. I'm using the distributed property here, which is 4x cubed. And then I'm going to do x squared times positive 5, which is plus 5x squared. I forgot a little square here, which I need to put in. Then remember what our next step was? It was to subtract. So we have to be careful here because you're going to subtract both. So you're using the distributed property of subtraction. So it's going to switch both these signs. This is going to become a negative 4x cubed, and this is going to become a negative 5x squared. So 4 minus 4, this basically cancels out. 13 minus 5 gives you 8x squared. And just like we did with long division, we brought down the next number. In this case, would be a term. Again, ignore the plus 5. Look only at the 4x and now the 8x squared. 4x times what gives you 8x squared? That would be 2x. And I'm going to write a positive 2x because I want, when I multiply the 4x and the 2x, I want it to be the exact same term. And then when I subtract them, it'll cancel out. So I write the 2x up here. Now I'm going to do 2x times both of those terms, and I'm going to write it underneath. I get 8x squared. That's the goal, to get the exact same number in term and variable. 2x times 5, that's a positive 10x. And remember what we do next? We subtract. But we have to be careful because it's going to switch both of the signs. 8x squared minus 8x squared, that cancels out. negative 2x minus 10x. That would give us a negative 12x. Be careful of that. Bring down the minus 15. Now my cat is running around like a madman. So now we're going to, again, ignore the positive 5. We're going to do 4x goes into negative 12x. How many times does 4 divide into negative 12x? Or 4x divided into negative 12x? That would be negative 3 times. So we're going to put the minus 3 up here. Negative 3 or minus 3 times 4x is negative 12x. We want these to be exactly the same. Negative 3 times positive 5 is negative 15. Then we subtract. And when we subtract, we have to subtract both terms. Negative 12x minus negative 12x is negative 12 plus 12. That cancels out. Negative 15 minus a negative 15 is negative 15 plus 15. That cancels out. So we get a remainder of 0. So what this tells you is that this cubic is factorable, and 4x plus 5 divides into it. And when you divide 4x plus 5 into it, you get x squared plus 2x minus 3. So 4x plus 5 is a factor of 4x squared, or 4x cubed plus 13x squared, as is this quadratic. So we have technically used long division to factor. Now we can try to factor this quadratic. This is a quadratic that's easy to factor. It's x plus 3, x minus 1. If you're not sure how I got that, you could do the long process that I've taught you with splitting the middle term, coming up with the two numbers, then factoring by grouping. Now, once I have written it as a product of its factors, this is the cubic written as a product of factors. This can be used to find the zeros. And you guys are good at finding the zeros, the roots, etc. And the zeros would be negative 5/4, negative 3, and positive 1. All right, I would like you to try B. I know it's complicated. You're going to get it though. So I want you to try B. In the next video, I'm going to start with this entire workings to B, and we're going to go from there. Good luck.